sets. So today, as I said last class, today I'll be taking on the number systems to give you to brush your views on number systems. So let's start with the question. This question: what are numbers? Hey sir, come on! Do not ask this question to class 11th people. I mean, I know you guys might be thinking that, but still, I would like to ask these questions to you. This question to you, and try to give an answer. And I know that I cannot hear you, but do try to answer this question. What are numbers? What do you think numbers are? Something that is used to count? Yes, it is. But then, is that all? What about these numbers? 1 by 2, 1 by 8, 3 by 2, 22 by 7? How am I supposed to count these numbers? Can I? So let me say, maybe you might give me this example of a pencil, and if I break a pencil into two, then I get two halves. Yes, so I can count halves. Do you count halves? I can still count this as 1 plus 1 is equal to 2. Why should I even mention half or quarter or 3/4, anything like that here? So we see that numbers are just not used for counting. Numbers are also used to measure things. So when I measure this small thing with respect to this whole pencil, then I can say that half plus half is equal to 1. That means I can only call this a half when I'm considering this as part of this pencil. That means I'm measuring this part with respect to this whole pencil. Then I can say half plus half is equal to 1. So let me add something more to that, something that is used to measure. Yes. Now again, is that all? Then what about these numbers? Minus 1, minus 2, minus 24. What am I going to do with all these minus things? All the negative numbers, what am I going to do with all these negative numbers? Now let's look at another example. I have a set of apples. Okay, wait, don't think that I'm going to teach about apples here. That your biology teacher will take care. I hope so. Okay, so here you see that I have a set of apples, and in this basket I have 5 apples here. Now Charles sir took away 2 apples from me. So let me put the number 2 here. Joy Samuel sir was very kind to me, and he gave me 3 apples. 3. And Dijo sir came and gave me 5 more apples, and I put the number 5. But then Rejoice and sir came and took away 4 apples from me, and I put the number 4. Guys, now look at this. You see 4 numbers here. By just looking at these numbers, can you understand who gave me the apples and who took away apples? By just looking at these numbers, do you get any idea who gave me and who took apples from me? All numbers, it all looks like people gave me the apples, right? So now if I tell you and I ask you how many apples are with me at the end of all this drama, how many apples are with me? How will you answer these questions? How will you answer that question by just looking at these numbers? It's not possible. So that is why we give them signs. Minus 2, meaning 2 apples were taken away. Plus 3 apples were given. Plus 5 apples were given to me. Minus 4 apples were taken away from me. Now if you tell me, if I ask you to tell me the answer, you just have to add these up and then add the number to this number. Minus 2 plus 3, 1, plus 5, 6, minus 4, 2. 2 plus 5, the answer is 7. So now, because I included these negative numbers, now I know that my total answer is 7 apples. So let me add one more thing, something that is used to compare. So again, what are numbers? Something that we use to count, measure, and compare. Now, do we use all types of number for these things? No. To count, we use natural numbers. To measure, fractions. To compare, integers. Right? Now, rational numbers. Okay, before I go to rational numbers, let me do something else. Let me take you to this system called number system. Here you see there's a number line, and there are many numbers on this number line. Now this is 0. Here there are positive numbers going, here there are negative numbers going. Now these numbers keep on going to where? To infinity, right? And these numbers to the left side of 0 keep on going to minus infinity, right? Right? So these, now that is this number line. Now what numbers that we use to count starts from 1, right? When we have to count something, we don't start counting from minus 3, right? We start counting 1, 2, 3. So these numbers starting from 1 to infinity are called, starting from 1 to infinity are called natural numbers, because naturally we use them for counting. Sounds nice, right? Natural numbers, naturally we use them for counting. Now the 0 is left out here, we see, but when we include 0 also, then again to infinity, that system of numbers is called whole numbers. Whole numbers are basically natural numbers with 0 also included in it. Okay, so why are they called natural numbers? Because naturally we start counting from 1, and whole numbers is just adding a 0 with natural numbers. Now is that all? No. Now we covered the first part, something that is used to count. Now let us look at something that is used to measure, fractions. Now when we look at fractions, we see what are fractions or rational numbers. Fractions are also called rational numbers. Now what are they? Look at this, something that can be expressed in p by q form. See, p by q, 1 by 2. See, something that can be expressed in p by q form. So rational numbers are something that we can represent in p by q form, provided that q is not equal to 0. Provided q is not equal to 0. I know my q doesn't look that nice. Usually it does, okay, but now I don't know why. Okay, so any number, if you can represent it, or if you can write it in the form of p by q, provided q not equal to 0, then that number is a rational number. So we said all these numbers are rational because all these numbers can be represented in p by q. Example, see, if you look here, 1 by 2 minus 1 by 2. See, so we covered that part, something that is used to count. Let us look at the other one, something that is used to measure. Again, let us just go to whole numbers. When we look here, we see all these numbers and all these negative numbers. So all these negative numbers, and all these positive numbers are called integers. All these negative numbers and all these positive numbers together are called integers. Now guys, if you notice something, I represented integers, rational numbers, whole numbers, natural numbers. All these numbers are represented on the same number line. Do you have a doubt of rational numbers? Then just look at this. If I can write 1 as 1 by 1, I can write 2 as 2 by 1, right? I can write 3 as 3 by 1. So all these numbers I can write it as p by q form, and q is not equal to 0. So rational numbers, integers, rational numbers, integers, whole numbers, natural numbers, all these numbers I am able to write, I am able to show in the same number line system, right? Now all these numbers together are known as real numbers. Okay, now let me just tell you something just for your information now. That is, all the numbers in the world, all the numbers in mathematics, in the branch of mathematics, all numbers are divided into two categories. One is real numbers and the other category is imaginary numbers. Now I know you have not studied about imaginary numbers, but you will study that in +1. You will study that in the coming chapters. Now, so there are only two types of numbers in the world in maths, that is imaginary numbers and real numbers. Why are they called imaginary numbers? Because those are only in the imagination. Exactly, it is not a joke, it is actually true. They are only in imagination. Now why are they called real numbers? Because they are real. As I said in the last class, whenever you see terms, try to understand the meanings by just looking at the name itself. Now these real numbers are divided into many categories, and one is natural numbers, and then sometimes also we can also say as whole numbers, and then rational numbers, and then we have irrational numbers, and then we have integers. Okay, so I'll come to that again later. So you guys understood till this much, right? So I wanted to show you that all these numbers can be represented in the same number line. Let's go back to a PPT. Rational numbers. Any number that can be represented in the form p by q, provided q not equal to 0. For example, 1 by 2, 1 by 8, 3 by 2, 22 by 7. Now irrational numbers. Any number that cannot be represented in the form p by q. For example, root 2. Now why are they called irrational? Because they are not rational. Okay, now root 2. What is the problem with root 2? Why am I calling it irrational? Because this is the value. Oh man. Oh yeah, test. Oh wait, it doesn't even end here also. It just keeps going. So that is why this number I cannot say a numerator and I cannot say a denominator for this number. Because it doesn't end, it just keeps going and there is no pattern. See, if you see, there is no pattern that keeps repeating. You just see many numbers coming in random. So this is a irrational number because I cannot and it is impossible to represent it in the form of a fraction. Let me give you another example. Root 3. What is the answer? What is the value for root 3? I'm sure that you won't even think of reading all these numbers out. Now, see again, it doesn't end. Keeps on going. I cannot represent that in the form of a fraction. So that is why these numbers are called irrational numbers. Now let me show to you one more irrational number. A famous irrational number. Okay, Vaya, one more thing. For calculation purposes, we cannot use all these numbers, right? I mean, you would not even think of reading out all these numbers now. So for calculation purposes, we only use the first numbers till the first three decimal places. Okay, usually we only use till the first three decimal places. Okay, now let me show you one more irrational number, pi. You heard of this pi many times, but do you really know what pi is? What do you think pi is? I know that I cannot hear you, but just try saying, what do you think pi is? Some people will say it is 3.14. Is it? Isn't 3.14 a rational number? 3.14, I can write it as 314 by 100. How is then it then a rational number? And some people will say it is 22 by 7. Very confidently they will say 22 by 7. But is it 22 by 7? Yeah, 22 by 7, come on. It is p by q form. Q is not 0. It is obviously a rational number. Then how is it possible? How is it? So what is pi? So pi is neither 3.14 nor 22 by 7. As I said, 3.14 can be written as 314 by 100. Pi is the ratio of a circle's circumference to its diameter. That means pi is basically a fraction with the numerator as the circle's circumference and the denominator as the circle's diameter. That is, pi is equal to circumference by diameter. Pi is equal to circumference by 2 times radius. What is diameter? 2 times radius. Same thing. Diameter is 2 times radius. You have always seen, this is not a new formula, you have always used this formula, 2 pi r is equal to c. 2 pi is the circumference of a circle is equal to 2 pi r. From this I just took the value of pi. Pi is equal to c by 2r. So to prove this, I'll give you one work. What you can do is draw two circles with any radius, different radius, okay? Two circles with two different radius. You can choose any value of a you draw whatever big or draw whatever circle you want and calculate the value of pi up to 5 decimal places. Try it out. Any size, any circle of draw a circle of any size and try to calculate the value of pi. And then this will be included in assignment. So then you can send me. Then you can tell me. Then you also can see how much what is the value of pi. Now yeah, let me show you something else too. I'll show you one property of irrational numbers. See, the problem of irrational numbers is that we cannot find a fixed value for them. Okay, now look at point A. Point A is 7, 0. Okay, now this is very easy, right? 7 is very easy. See, if you look carefully, 7, how much ever I zoom and how much ever I go deep, 7 remains at 7 itself, right? Point A remains at 7 itself. Now can I do the same thing with irrational numbers? 7, I can write it as 7 by 1. It is a rational number. But can I do the same thing with irrational numbers? Let's see. Let's look at let's look at pi. B. Pi, I have labeled pi as B. Where is B? B is here. Okay, let us go and see. Look at B. This is pi. Now let us see. Pi, you remember pi's value was around 3.14 blah blah blah, right? So it comes between 3 and 3.5. Yes, let us go. Comes between 3.1 and 3.2. Yes, let us go. See, if you keep using it, never comes at a point. See, it never comes at these lines. It just keeps on being in the middle of these two lines. See that this point pi keeps on being in the middle. See, it keeps on, it tries to come nearer and nearer to the line, but it doesn't come. It keeps on staying in the middle. That is why, that is a proof that pi does not end. The value does not end. It keeps on going. So that is why we cannot find a fraction. We cannot find pi as a ratio. Now let's look at another example. We looked at pi. Let us look at root 2. Root 2 is also a rational number, so we expect the same thing to happen. Now root 2 I have labeled C. Let's look at root 2. Root 2 also, see, it should come around 1.414 blah blah blah. So let us look, it is between 1.4 1.5. Good. Let's keep going, let's keep going, let's keep going. Oh, again, see, same thing. It does not join at any, see, it is very near to this line, but it does not come at exactly at that point. See, if you zoom, it never comes near that line. It just appears to be nearer, but it is again and again and again staying in the middle. See, again and again it's staying in the middle of two lines. So that is a proof that it is very difficult, not very difficult, it is impossible to find the correct value of root 2 or pi or any irrational numbers. That is why these numbers are called irrational numbers. Okay, so let us go back to our PPT. Yes, now what did we see and why did I show you all this? We saw natural numbers, we saw integers, we saw rational numbers, we saw irrational numbers. Now I showed you that all these numbers can be shown in the number line, and all the numbers in the number line are called real numbers. Are you able to relate this with our chapter? What are we studying? We are studying about sets. Now all things, everything that is included in natural numbers, everything that comes under natural numbers are in real numbers, right? Everything that comes under the topic integers are there in real numbers. Everything that comes under the topic rational numbers are there in real numbers, right? What are these things? These things are elements, right? Elements. Every natural number, every element of natural number is a real number. Every integer is a real number. Every rational number is a real number. Every irrational number is a real number. So what are these things called? Subsets. This is a set of natural numbers. This is a set of integers, and every element of this set is there in this set, this higher set. So these small sets are called subsets. And what is this set called? What is this main set called? Universal set. Now are you able to relate to what we studied last class? So this is what I wanted to explain to you today, and so this is all about the number system. And I know that I mentioned something called imaginary number systems, which I'll teach you later, because that comes as a very different chapter, and God willing I'll take that topic when that chapter comes. So as of now, this is all that I want to say in this video. And again, I'll be sending assignment also in this. I will be sending assignment in this also. Do try to complete them, and if you have any doubt, try to contact me as any way possible. Please remember, students, that it is very difficult for me to teach you without seeing your faces, because I am not even sure whether you are understanding what I am saying from here. So remember that I am very open in receiving doubts from you people, and will try my best to solve them and give you a right answer for them. So do try, do ask me if you got any difficulty in solving any of the assignment questions, or if you find a doubt, or if you feel that I said something wrong. So yeah, thank you students for listening to me. Do well.